remember in our first time through this section too, we also talked about change of variables, and so um, this is just a reminder of change of variables in double integrals. So we had this d star region in D. D star was in the UV plane, D was in the XY plane, and then we had transformation mapping between them. Bijective is, if we haven't come across this word, it's just a very nice way of me being lazy, but it also means one-to-one and onto. Okay, it means that we have a one-to-one function and it's onto, so it's injective and surjective. Okay, and it's a C1 mapping. Okay, great. And then all this really allowed us to do is map from domain D to this domain D star that perhaps had a nicer parameterization. And then remember we had this extra expansion factor here, d of xy over d of uv, and so that was just a matrix where it was a change of coordinates matrix. Okay, so that is fun, and now we have the triple integral version. Okay, so w and w star. Okay, w star is over in the uvw space, w is in the xyz space, and then we say, well, the notation hell, but we'll just deal with it. G over domain W, and then again, same sort of thing. We just stick the parameterization that we have for X, Y, and Z in terms of U, V, and W in, and then we have this expansion factor. And that expansion factor is actually just a Jacobian. Okay, so again, all the matrix of partials, and we find the determinant, and we go on with our life. All right, so these next two, they're kind of examples, but they're kind of just more like, well, they're going to be useful for us in our lives going forward. So we want to find the Jacobian switching from Cartesian to cylindrical. Well, we might have to remember that, okay, we've used this enough recently, but x is r cosine theta, and y is r sine theta. And then z is just z. Okay, so then we say that the matrix d of x, y, z with respect to d of r theta and z is the determinant of cosine theta. And then, so this is everything with respect to r, so cosine theta, sine theta, and 0. And then with respect to theta, we get r negative r sine of theta, r cosine theta, and 0, and then we get 0, 0, z. Okay, and then you can expand this however you like, or if, 0, 0, 1, or if you're good at putting this into Wolfram Alpha, just to check, because I know that you all can do this by hand, you end up with just r. Okay, so really our expansion factor when we're switching hasn't changed that much, so just remember to include that expansion factor of r. Okay, and then similarly when we switch to spherical, okay, just again a quick reminder that in spherical we have x is the same as rho sine phi cosine theta, and then y is rho sine phi sine theta, and then z is rho cosine theta, or cosine phi. Okay, so then when we take the partials, this one isn't as pretty, but we're going to do it and build some character, okay, with respect to rho, theta, and phi. Oops, and then we're going to do it in the other order, phi and then theta, okay. Again, just remember we can always reverse those. All right, so everything with respect to rho first. This is the easy one, so sine of phi, cosine of theta, sine of phi, sine of theta, and then cosine of phi. Okay, and then now with respect to phi, we get rho cosine phi, cosine theta, rho cosine phi sine theta, and we get negative rho sine of phi. And then the last column, we're almost done. And then with respect to theta, so we get negative rho sine phi sine theta. And then we get rho sine phi cosine theta. And then 0. Whew, that was fun. And when you get all this done, you end up with rho squared sine of phi. All right. So, might be useful in some problems coming up. And again, just remember to include this as you change those variables. All right. So in the next couple of videos, we'll go through some examples and we'll be done.